For our physics video, our overall objective was to calculate the K value of my mountain bike shock. To do this, we measured the displacement of the shock as we drove the bike off the curb. We measured the displacement of the shock by tying a small piece of string before it was compressed around the shock. After the compression, the string stayed at the same height as the distance traveled by the spring, which we then measured with a ruler. Before we decide on how to solve the problem, we need to pick a lens. And so, if we look at the motion of the biker, we can see that before he goes off the curve, he has gravitational potential energy. And afterwards, the energy is stored in the spring. And so, because the energy is transferred from gravitational to spring energy, we conclude that the lens we use is energy.
To find the K constant of the shocks on the bike, we first need to find the gravitational potential energy of the system before we went off the curb. To do that, we first found the mass of the system by adding the mass of the bike and the mass of Brooks. Since we already know the gravitational constant, then we just needed the height of the curb, which we measured. And we plugged that into the gravitational potential equation, and we found this. Then, since we know that gravitational potential energy plus kinetic energy is equal to the potential energy of the spring plus kinetic energy, because energy is conserved, and we also know that we're not accelerating, then we can cancel out the kinetic energies and set the potential energies equal to each other, which we've done here. Now, we just plug our values that we have into the potential energy of the spring equation, and we have found the delta x of the spring by measuring the distance traveled by the string, and here we find the K constant.
After calculating our initial K, we did the experiment again with Adam riding the bike instead of Brooks.
To receive more accurate results, we repeated the procedure using Adam on the bike, giving us a different mass. We calculated a new potential energy, which in turn gave us a new K value. We used this K value plus the K value from the previous experiment, and we divided it by 2 to find our average K value for the experiment here. The reason there might be variation between this K value and the previous one is that different riders shift their weight differently on a bike.
So, to conclude, the average K value of 5.67 times 10 to the 4th newtons per meter we calculated is most accurate due to the differences in rider weight distribution.